Hey everyone, so here is part 3 of the lesson 4 notes. We're now going to talk about how do we use our h and k to graph when we have now cube roots. Okay, so we're really going to do the same process as we did with the square roots. So as long as there's an h, k, or both, we must first graph the parent function. Okay, so here, remember our parent function is a and then the cube root of x, okay? So for this one, notice that our h is going to be here. This is our k value, so that's going to tell us how we're going to translate later on. So our parent function, once again, I'm going to do different colors to help us out. Okay, so our parent function is going to be y equals -3 times the cube root of x. Now, when we talked about graphing cube roots, remember we're going to use actually 5 numbers here. So remember we can use both positive and negative numbers because we can take the cube root of a negative and we just get a negative at the end. So we use -8 because that is a perfect cube, -1, that is also a perfect cube, 0, 1, and 8. Okay, so when I plug -8 into my x, the cube root of -8 is -2. I multiply it by -3. That actually gives me a +6. Okay, when I plug -1 into there, cube root of -1 is -1 times -3. That should give me +3. If I plug 0 into there, remember that's just going to give us 0. Okay, now remember what happens with our numbers is that we actually get the same numbers, it's just the signs change. So the numbers repeat, it's just that signs are always going to switch. So here when I plug 1, remember cube root of 1 is 1 times -3, that's how we get that. And then same thing here, cube root of 8 is 2 times -3 is -6. Okay, so let's go ahead and graph the parent function. So we got -8 and then +6. And then we get -1 up 1, 2, 3, 0. There we go. 8, 6. There we go. And then once again, because this is my parent function, I'm going to go ahead and make it just dashed. There we go. Okay. So now that we have done our parent function, now we need to talk about the translations. Okay. Now remember, h is always going to be the number inside the radical, no matter if it's a square root or cube root. Now remember, h is the opposite of what we see. So here we see x plus 4. What we need to do is, actually we do the opposite. So we're actually going to translate left 4. With our k value, we translate exactly as what we see. So k is -1, so we're going to go down 1. So just like we do with our square root, so the last example, basically we are going to take each of the points and we're going to move them left 4 and down 1. And then once again, there's one that's just going to kind of go off the graph. That's okay. That's going to happen. Oops, I think I went the wrong way, guys. I went to the right instead of the left. Okay, I gotta change these. I'm sorry, guys. We're trying to go to the left, not the right. So some of you may be wondering, like, what did she just do? Okay, let me redo this because just realized I have to go to the left 4, not right. Okay, so go to the left 1, 2, 3, 4. Once again, we are going to have one probably just a little bit off the graph. That's okay. So over 1, 2, 3, 4, down 1. There we go. Now this would be correct. And one more. There we go. Okay, now this is the correct graph of this cube root. I moved each point left 4 and down 1. Okay, now here's the nice part with cube roots. Really, when we think about domain and range, notice that with cube roots, no matter how much we translate, they will have arrows on both sides. So when we think about domain, notice that we have an arrow going to the left and an arrow going to the right. That means our domain every single time for all cube root functions will always be -infinity to +infinity. So no matter what. So when you actually see these problems like cube root of something and they ask you for domain, you'll know it's always -infinity to +infinity. For range, this is actually also the same. Because notice that this arrow that's going to the left, not only is it going to the left, but it's also going up. So that means we do go to positive infinity for our y's. The arrow that is going to the right, not only is it going to the right, but it's also going down. So we go to negative infinity. So the domain and range for every single cube root function, no matter what, will always be negative infinity to positive infinity. So when you guys are doing these problems, automatically do the domain and range because they will always be negative infinity to positive infinity. Okay, let's look at our next example. Okay, we have y equals 2 times the cube root of x plus 3 minus 5. So now this is what I would like you guys to do. I would like you guys to pause the video and try this entire example on your own. So go ahead and do that. Okay, here's what you should have gotten. So our parent function should be y equals 2 times the cube root of x. So that's our a times the cube root of x. When I go ahead and graph that, here's my xy table of what I got, and then I plotted those points. Now, when I look at my function, remember h is always going to be inside the radical, no matter if it's cube root or square root, and then k is always going to be on the outside. Remember, h is the opposite, so when I see x plus 3, that means we actually translate left 3. And then k with being negative, that means we go down 5. So I took each of the points, I went left 3 and down 5. And then as a reminder for domain and range, it is always the same for every single cube root function. So that's always going to be negative infinity to positive infinity. Okay, if you have any questions, let me know. So you can always email me, come to Tiger Time when I'm available, or before or after school when I'm available. I'll see you guys later.